Okay, bro. So first question is we have to find the parity check matrix. We know that the generator matrix can be written as I of 2 in this case because this identity matrix of size 2, and then you have the A matrix. H is always going to be A transpose and then identity element of n minus k. So that's 5 minus 2, that's 3. Therefore, H will be A transpose is Iska transpose. So that will be 1 1 1 1 0, and then identity matrix of size 3. This is H matrix. Next question is determine all code words. Now, the syndrome is the value you get when you multiply H by the value of the received code word ka transpose. If that is equal to 0, that means that this is a valid code word. Okay, so now we'll exploit this fact. Let's take H 111 110 100 1, and now the received word, which is the encoded word after transmission and some noise and all, will be of size 5. So that will be x1, x2, x3, x4, x5, and let's say that this is equal to so this is a 3 cross 5 matrix, 5 cross 1. So this will be a 3 cross 1 now thing. So that will be 0 0 0. Okay, let's solve. So x1 plus x2 plus x3 is equal to 0. x1 plus x2 plus x4 is equal to 0. x1 plus x5 is equal to 0. From this you get that x1 plus x2 is equal to minus x3. We're working with modulo 2. In modulo 2, minus x is the same as x because each element has its own inverse. So now you can say x3 is equal to x1 plus x2. That's the same for x4 also. You can also say x5 is equal to x1. And the length of the entire code word is 5. So let's start writing it down. Let's x1, x2, x3. Let's look at all 8 possibilities. 0 0. Then x. Wait, I'm sorry, I fumbled. It only depends on x1 and x2. So you just need to write x1 and x2. X3, x4, x5. x3 is x1 plus x2. That's the same as x4. x5 is just the same as x1. So our code was a 0 0 0 0 0 0 1 1 1 1 0 1 0 1 1 1 1 1 0 0 1. Now next question is find the decoded word for the message 11101. I'll go to the next page. So now you take your H matrix 1 1 0 0 1 1, and then you multiply it by the message that you got. So that's 1 1 1 0 1. Perform matrix multiplication. It's 1 plus 1, that's 0. 1 plus 1, again 0. 1 plus 1, 0 0 0. 0 0 0 means that our syndrome is 0 0 0. That means that this word is a valid code word. So now we need to find the original word. Now this particular type of encoding and decoding, there's a name for it. I forgot what it's called. But basically it says that the original word is embedded inside the encoded word as the beginning part of the encoded word. So in this case our original word is 1 1. Okay. What is error detection and correction capability? For this, you have to take all of the encoded words that you found. So that's all zeros. Let me just copy it. Then 0 1 1 1 1 0. Then 1 0 1 1 1. Then 1 1 0 0 1. Yeah, so now you have to find the minimum Hamming distance between any two pairs. So you have to find the Hamming distance amongst all of the pairs, all of the possible pairs, and choose the minimum one. Hamming distance is the difference in each bit of the word. So for example, Iska and Iska Hamming distance would be 3. Let me see if I can just figure out the minimum Hamming distance by eye, because it's not fun to find Hamming distance. Yeah, I think it's 3. I can't find anything that's 2. You calculate and tell me, what is minimum Hamming distance? What is Iska Hamming distance? This is 4. Yeah, so I think it's 3, and you can get 3 with this. Then in that case, error detection and error correction. Error detection you can do up to this -1, so that's 2. Correction up to this -1 divided by 2, so that's 2 by 2, 1. This is my answer. It depends on whether this Hamming distance is correct. You solve and tell me if it's correct. If it is, then we're good to go.